Hello, we're going to continue with lecture 3 in Analytics for Business and Economics. And in this lecture, we're going to take a first look at R. So I'm going to take you through a example process of doing real statistical analysis in R. I don't expect you to be able to replicate what we do in the lecture yet. By the end of the class, I think you should be able to look back on this lecture and say, yeah, I can do that. Um, as of right now, I may go a little too fast. It may go through. You can always pause and look back, but I really don't want you to think about trying to comprehend every single step and be able to replicate every single part of this lecture. What I really want you to do is just get a general overview and sense of, well, what does it look like to work in R? I want to give you kind of the bird's eye view of where we're going, because we're going to get lost in lots of details throughout the class. It's helpful to kind of know, well, what does it look like from above before we get down into the weeds? All right, and that's exactly what this lecture is all about. So let's take our first look at R. And the first thing we really want to understand is kind of the fundamental data structure in R, and it's called a data frame. So a data frame is essentially a two-dimensional data structure that's similar to a table in a spreadsheet, or an SQL database, if you know what that is. Doesn't really matter if you don't. Think of it as one page out of an Excel workbook. You have each row represents a single observation, and each column represents a distinct variable or attribute of that observation. Columns can store different types of data, say numeric data or a factor data, so categorical data. That's what a factor is, category data. We'll talk about that in module 2 when we talk about chi-squared testing and looking at and dealing with categorical data. Character data like text, in Excel it'd be called text. Logical data, so true, false, etc. There's various different types that we can talk about. Those are the big ones, though, that we'll deal with would be numeric, factor, character, and logical. All right, but the data within each column has to be the same type. So we don't want to mix types within columns, but this just goes back to kind of good management of your data. Each column is a distinct dimension, all right? It's a distinct variable. You don't want different types of variables in one column. So, for example, if you wanted the zip code and the state for an address, it would be much better to have those in two different columns because the zip code is a number and the state might be a two-character abbreviation. All right, it's easier to deal with that way. In any event, we're going to use an example of a preloaded data set that just comes with R called MT cars. MT stands for motor trends. Cars it's a data set of a bunch of cars that was collected back in the late 1970s over some cars back then. It has things like miles per gallon and other stuff. It's not a particularly interesting data set for anything particularly in and of itself, but I don't know. It's just it's a built-in data set, so it's easy to get at. So the first thing we're going to do is we created last time this first markdown, our markdown file. We're just going to work in that. Okay, and I want to show you a little bit more about that. So we're going to do, this is going to be what, lecture 3. So we'll call this first look at R. Okay, just give ourselves a heading so that we know what we're doing. And the first thing we want to do is we want to load this data, this MT cars data set. So I'm just going to go ahead and I'm going to create a new data chunk or a code chunk right here by clicking the C button right up here and then telling it I want it to be R. There's other things we could put in there, but we're not going to worry about that right now. We're just going to worry about making it an R. And then I'm going to use a function called data. And what the data function does is it says, okay, go find the MT cars. I'm gonna tell it, and you can see right here all these data sets. These are built-in data sets that are showing up right here because you've got this kind of code completion feature in RStudio, and these are all these ones in here. I'm going to start typing MT and boom, right at the very top, MT cars. All right, and it gave you a little definition of what that is. So let me just do that real quick. I'm here, it's not giving me that pop-up, so I'm going to hit the tab button, and there it does, MT cars, and boom, it gives me some information about it. Data was extracted from the 1974 Motor Trends US magazine and comprises of fuel consumption and 10 aspects of automobile designs from 32 different automobiles from 1973 to 1974. There you go. That's what it is, right? And I'm just going to run this. And well, it didn't do much, did it? Well, actually it did. Because if I come over here and I look up here in my environment window, MT cars is now in there. It says promise because, well, I haven't done anything with it, but it's actually been brought in as a data frame. So let's go ahead and let's just have a quick look at what the MT cars looks like. So oftentimes a handy function is called head, H-E-A-D, and then I'm going to put in MT cars, all right, because that's the name of my data frame, and it's just going to give me the first few rows of the MT cars data set, and you can see, there it is. So I've got things like miles per gallon, this is the number of cylinders, the displacement, that's how big it is, horsepower, no idea what DRAT is or any of this other stuff. So we're just going to say that's really cool. Yay. All right, bingo. So I've got all of these different things. You can see it looks a lot like just an Excel spreadsheet, right? I've got different measurements in the columns, and I've got a different car in each row, so different observation in each row. Easy peasy. That's what a data frame is. So, well, how do I use that data frame? Well, one of the things I can do is I'm going to use the $ operator. And what the $ does is it lets me reach inside an object like a data frame and get a part out of it. So right here, let's get a specific part. Let's get miles per gallon. So I'm going to go ahead and create a new chunk because it's just handy to have a new chunk so I can run little bits of the code at a time. And I'm going to type in MT cars. All right, and then I'm going to hit the $, and all of a sudden, poof, it gives me a nice list of all the columns inside of MT cars. So for right now, we're just going to pick miles per gallon. If we run that, bing, gives me all the things in miles per gallon. Notice the Mazda RX-4 got 21 miles per gallon. What's our first entry? 21. That's it. Okay, so we can do a few more things. Another thing we can do, we can summarize this data. It's oftentimes nice to have summary statistics. So we can use the summary function. And if I wanted to save it as an object, all right, I can use the assignment operator to say put whatever's here on this right-hand side and stuff it into a box named this. All right, in other words, I'm going to take a box, I'm going to name that box MPG underscore summary, and I'm going to stuff the summary of MT cars MPG, right? So the miles per gallon. I want to know summary of that. So let's do our MPG miles per gallon summary. I am lazy, so I'm going to call it sum with 2 M's to differentiate that from sum as in adding up. So sum as in summary. The assignment operator. Now this is important. Whenever we want to store a variable, we're going to use this arrow looking thing. That's called the assignment operator. Right? We could also use an equal sign. All right, that sometimes also gets used as an assignment operator. But to be honest, the equal sign has a more special use in R. We'll talk about this in the next point, but for right now, we're just going to focus on using this assignment operator. Then I'm going to use the function summary. All right, and boom, it brings it up. And you're wondering, how do I remember all of these functions? Well, for the most part, for this class, I'm going to give them to you, and there's not going to be too many for you to remember. But as you add more and more capabilities, more and more to your capabilities, you'll just start to remember them because you use them a lot. Right? It's a little like using Excel. There's a lot of functions in Excel. And, at some point you'll get to where you just Google, how do I do this? And at that point, you're able to really start learning on your own. All right, $ to get inside of empty cars, and we're going to do miles per gallon, MPG. And I'm going to run this. And, oh, well, crap, nothing happens. Well, actually, something did happen. So let's come over here. We can see, first of all, we have data, empty cars. That's a data frame, so we know that. And values, MPG sum, summary defaults. All right, so bing, we've stored something, but it didn't give us any output. To get output, we need to print that. So we could do print MPG underscore sum. But typing out print over and over again is annoying, so I'm just going to get rid of all of that and just type the variable again. And it will imply that I want it to print it out. And so if I do that, bing, I get, let me redo this real quick. I get the minimum, the maximum, the first quartile, the median, the mean, and the third quartile. All right, so this is 1, 2, 3, 4, 5. It's not quite called Turkey's 5 number analysis, but it's real close. All right, so the median is kind of the middle range. So 50% of the data is less than 19.2. 50% of the data is more than. The mean is just the average. Third quartile is like the 75th percentile. First quartile is the 25th percentile. You remember that from Econ 326, or Econ 226, I'm sorry. And the max and the min, that's self-explanatory. And there's my summary, bing. All right, so that's the first thing I want to do. Next thing I might want to do is I might want to look at a relationship, right? I might be interested, what's the relationship between miles per gallon and horsepower, right? Well, one of the great ways to do that is with a scatter plot. So let's do that real quick. And so we're just going to start out. I'm going to get a new code chunk here. All right. And the first thing I need to do is I need to tell it what my X and my Y are. So there's a couple of ways to do that. We're going to do it here by assigning it as X and Y. So we're going to type plot. All right. And then we're going to do X. Now, whenever I have an argument, and R uses these cool things called named arguments. So I don't have to worry about what order these things are in. Like if you remember an Excel formula or an Excel function, you've got to do it in the right order, and that's how it knows which argument is which. R doesn't care about the order because you're going to give each one a name. So the first one I'm going to do is I'm going to say X, but here's where you use an equal sign. So inside of a function, when you're assigning values to different arguments, like, okay, what's the X variable going to be? What's the Y variable going to be? We're going to use equals. So X equals empty cars, $MPG, or I'm sorry, no, X is horsepower, because that's our explanatory variable. And our dependent variable, Y equals empty cars, $miles per gallon. And if I just plot that, just like that, what do I get? Bing, I get very similar kind of plot to what I had before. The only difference is one, well, that's not very nice. All right. I'd rather it just said horsepower, like over here. Oh, and this is not very nice either. This label is not very nice. I'd rather it say miles per gallon. And it'd be cool to have a title, right? Well, we can do all of that. The first thing I can do is, oftentimes it's easier to read a function if what I do is I put each argument on its own line. And I just add a comma. All right, and I'm going to put that in there. The only real downside to that is when I hit the tab button, it doesn't work. All right, if I'm up here on this first line, if I hit the tab button, okay, I can pull up all the possible arguments, which is kind of nifty. And one of the ones I want to do is, the X label. All right, so what's my X label? That's going to be horsepower. Right, ooh, and I don't need to capitalize the P. There we go. Bing. Now I'm going to just click down here and give it a second. All right, come on. Well, it's not underlining in that in red. It should because I forgot a comma. Oftentimes, if I do something wrong, like let's try this. That's wrong. I don't know why it's not doing it. If you have something wrong with the code, it'll flag it so that you can see and you'll have to fix it. Okay? So, and I can put that on its own line if I wanted to, just like that. And notice I'm doing it in a different order than what I did in the lecture notes. That's perfectly okay. I don't have to. YLab, so that's Y label equals, and we're going to call that miles per gallon. Bingo. I'll put comma. The only thing that's a little challenging is the very last argument should not have a comma after it. So now I'm going to, and this one's a goofy one. It's called main. That's the title for the graph. I don't know why it uses the argument main, whatever. Miles per gallon versus horsepower. There you go. I run this. There you are. We've replicated that plot. And the dimensions are a little different because I haven't knit this yet, but when I knit it, it's going to look very, very similar. Assuming I haven't messed something up. Maybe I did mess something up. Don't think so. No, it did. Oh, I'm sorry. It's right here. I just forgot to look there. Boom, I get something almost the same. Okay, so there's plotting that. So that looks pretty cool. Well, the next thing we might want to do is I might want to fit a best fit line through here, right? So oftentimes we call this a trend line. I'm not sure. It gets called a trend line a lot. I don't think it's quite the right title for it, but what the heck, that's what it gets called, so we'll just call it here. So the first thing we have to do is we have to get a trend line. So I'm going to go ahead, I'm going to create myself a new code chunk, and I'm going to use a new function. So I'm going to call this fit. All right. And I'm going to use the assignment operator, and then I'm going to use LM, that stands for linear model, or linear regression. And then I have to use a formula. Now, don't worry about what a formula is just yet. We're going to have a whole lecture on it, and don't worry about any one of these points. If it doesn't make sense, we're going to have whole lectures on all of them. This is just to give you an overview, kind of a taster, if you will. So MPG is my dependent variable. Tilde. All right, I told you we're going to use those tildes and back tabs. Probably more in this class than you ever have before. And HP is my independent variable or my explanatory variable. And then I have to tell it where to find those. So I'm going to say data equals MT cars. And that says where to find that data. And when I do that, guess what? Nothing happens, right? Because I stored it all in this function, in this object called fit. Now, here's something that's really cool. I'm going to highlight that whole line, and I'm going to type open parenthesis, and look at that. It just put the whole thing into parentheses. That's kind of cool. Once you get used to it, it's kind of fun. And when I put it all in parentheses, what is it going to do? It's going to print it out. And I get an intercept and a coefficient here, and it gets the equation, the intercept and the coefficient for this red best fit line. Okay, but that's okay. We don't really need that for right now, so I'm going to get rid of those parentheses. Okay. Then what I'm going to do is I'm going to come up here and I'm going to grab this code up here again because I don't want to retype it all out, and you don't want to watch me retype it all out because that's boring. come right down here. I'm going to paste this in. Bing, same as before. And I'm going to add one more command. It's going to be called AB line. And then I'm going to tell, I want it to put as a line, I want to use fit. All right, and let's make the color, we don't have to make it red, we can make it blue. Because remember, if you can't make it good, make it blue. And something kind of neat about our Markdown, or I'm sorry, RStudio, is anytime you're doing code and it sees it's a color, it tries to highlight that color, the color that you pick, so that you can visually see what you're doing. It's kind of fun. And Bajinga, there we are. We have the same graph as before, as here, only instead of a red line, we got a blue line. If you like blue, you could do green. Or, you could do a color picker and actually put in a hex number. So like, for example, say I want it to be black. Oh, actually that's white, sorry. There you go. And then you end up with black. All right, and then you can pick any color that your monitor can represent. All right, there we are. So next, let's do a complete example from the chapter. What are we doing? We load the data. We summarize the data and look at that summary. We estimate some kind of model, right? So we want to look at some kind of relationship. So we look at how MPG is affected by horsepower. We plot out a scatter plot to show that, and then we add on to that the best fit line. And that's kind of a really brief, very simple analysis that can be done in R. And it can be done really quickly. And the really nifty thing about this is, let's say we come along next week and we have a new set of cars. All right, well, we just replace empty cars with the data in empty cars with the updated data set from empty cars, rerun it, and poof, everything is updated. All right, we'll talk to you in the next lecture.